Hey everyone, and welcome back to The Explainer. Imagine for a second that you and I are sitting trackside at a massive stadium right now. The crowd's roaring, you can literally smell the exhaust in the air, and there's this incredible, gravity-defying spectacle happening right in front of us. We are watching 5-ton behemoths launch themselves into the sky. It's just pure, unadulterated chaos. But when you look past the flashy paint jobs and the roaring engines, there's a fascinating puzzle staring right at us. Today, we're going to geek out and answer one specific, mind-boggling question. Exactly why monster truck tires don't burst under all that pressure. Okay, let's dive right into this.
A massive drop. A brutal landing. Seriously, why doesn't the tire burst? Think about it. If you took your daily commuter car, drove it off a ramp at these heights, and let it smash back down onto the dirt, well, let's just say your insurance definitely wouldn't cover it. The tires wouldn't just pop, they'd completely vaporize, and the wheels would shatter into a million pieces. Yet at every single show, you see these monster trucks flying over crushed cars, dropping out of the sky, and landing so violently that the ground literally shakes. But that tire? It's completely fine. It doesn't blow out, and it doesn't shatter. So how is that physically possible?
To really appreciate the engineering secret here, we have to grasp the sheer gravity of the problem. 10,000 pounds. We're talking about 5 tons of solid metal, fiberglass, and engine block hurtling through the air. Making a lightweight dirt bike survive a jump is one thing, but making a 10,000-pound piece of heavy machinery do it over and over again without catastrophic failure? That is an entirely different league of engineering.
And, it's not just the weight, it's the height, 30 feet. These trucks are routinely launching 20 to 30 feet straight up into the air. Dropping 10,000 pounds from what's basically a 3-story building is a literal recipe for destruction. The kinetic energy generated on the way down is staggering. By all laws of common sense, the moment rubber meets the dirt, that tire should explode like a water balloon.
So how do they survive? Our roadmap today comes down to 3 distinct physical components. First, monster truck tire engineering. Second, low-pressure, high cushion. And third, monster truck suspension explained.
All right, let's start with part 1, monster truck tire engineering. The Terra tire. These things are absolutely not just scaled-up versions of what you have on your car. They are a massive 66 inches tall. That's 5.5 feet. And what's really fascinating here is that they weren't originally invented for jumping over school buses. Actually, they were designed for heavy agricultural equipment and rugged military vehicles. They were built for traversing the absolute worst terrain on Earth while carrying immense weight. So right off the bat, they start with a foundation of extreme durability.
If you compare normal car tire rubber versus monster truck tire rubber, the difference is night and day. The rubber on a Terra tire is 3 to 4 times thicker than a normal tire. But here's the real kicker. It's not just thick, hard rubber. It's made from a highly specialized, highly flexible compound. When that 10,000-pound truck hits the ground, this thick, flexible rubber absorbs the hit by deforming and squishing. It's designed to flex instead of remaining rigid and cracking under the immense force.
Moving right along to part 2, low pressure, high cushion. This is one of the most counterintuitive facts in all of motorsports. You'd naturally think that a massive 5-ton truck tire would need hundreds of pounds of air pressure to stay inflated under all that weight, right? Well, it's actually the exact opposite. Take a look at an air pressure comparison. A normal daily commuter car tire usually holds around 35 psi, but a monster truck tire, it runs incredibly low at just around 20 psi. Think of it like falling on a mattress instead of a hard floor. Why do they run the pressure so low? Because lower air pressure means the tire stays slightly soft and squishy. It essentially turns this massive 66-inch tire into a giant air-filled shock absorber. Imagine jumping off a wall. Would you rather land on a solid, highly pressurized surface like a hard wooden floor, or would you rather land on a soft, giving mattress? That low pressure acts just like a mattress, allowing the tire to flatten out upon impact, vastly increasing the surface area and giving the truck a crucial cushion. And that brings us to part 3, monster truck suspension explained. Let's walk through the exact physical sequence of a landing, step by step. Step 1, you have that massive impact as the wheels touch the dirt. Step 2, this is where the magic happens. These trucks use customized, nitrogen-charged, long-travel shock absorbers. When the truck lands, these massive shocks dynamically compress by an unbelievable 3 to 4 feet. Just imagine the wheels moving up towards the chassis by almost 4 feet in a split second. Step 3. By allowing that much travel, The violent kinetic energy is mitigated and bled off way before it can overwhelm the rubber. The crucial takeaway here is summarized by one mind-blowing statistic: 90%. Those massive, long-travel shock absorbers actually eat up about 90% of the landing force. Only a tiny fraction of that violent, bone-shattering kinetic energy ever actually makes it down to the tire itself. Basically, the suspension takes the beating so the tires don't have to.
Have you ever noticed that right after a monster truck lands a massive jump, it does this little graceful hop? That signature post-landing bounce is exactly what we're talking about. That is your visual proof of those massive shocks doing their job perfectly. They compress wildly to swallow that 90% of the impact force, and then, as they release that stored energy, the truck bounds slightly back into the air. Without that bounce, without that suspension travel, all that force would have literally nowhere to go but straight out through the sidewalls of the tires.
So let's bring all of this together to understand monster truck jump physics. When that truck hits the ground from 30 feet in the air, three brilliant engineering solutions flawlessly dismantle the kinetic energy. First, you've got 3 to 4 feet of suspension travel that instantly activates, eating up 90% of the destructive force. Second, the remaining energy hits that mattress-like low air pressure inside the tire, which flattens out and cushions the blow. And finally, the uniquely thick, highly flexible Terra rubber stretches and deforms to handle whatever force is left over. It's an absolutely perfect chain of shock absorption.
So now you know the mechanical secret to surviving the drop. But there is a glaring question left on the board, isn't there? Why doesn't the driver get hurt at these extreme speeds and impacts? If the suspension and the tires are eating all that violent kinetic energy, what on earth is happening to the human being strapped inside that fiberglass shell? Well, the safety engineering inside the cab is just as insane as the physics outside of it. But we're gonna have to save that fascinating deconstruction for our next explainer. Thank you so much for hanging out with me today to explore the engineering behind the spectacle. Until next time, keep asking questions and keep looking at the engineering all around you.